Welcome to G Fun Facts Online. Today, we are abandoning the comfortable idea that the universe is a static, serene collection of starlight. Instead, we are looking at the violent reality of the cosmos, a place where destruction is the primary engine of growth. We used to believe in the island universe theory, viewing galaxies as lonely, majestic pinwheels floating in a void, disconnected from one another. That view is wrong. The universe is actually a chaotic ecosystem, where the strong devour the weak, where neighbors tear each other apart, and where the majestic spirals we admire are merely the temporary survivors of a cosmic food chain. This is the reality of galactic cannibalism. When gravity bridges the gap between two galaxies, the result is a cataclysm that defies human timescales. It is a slow-motion car crash lasting hundreds of millions of years. But to understand how a galaxy, a structure hundreds of thousands of light years across, can eat another, we first need to change how we think about collisions. In our daily lives, collisions are solid. Cars crash, billiard balls click. But galaxies are ghosts made of light and gravity. A galaxy is essentially empty space. If the sun were a ping-pong ball in New York, the nearest star would be another ping-pong ball in Atlanta. When two galaxies collide, the stars themselves almost never physically touch. They pass through each other like two swarms of bees. If the stars don't hit, how does the violence happen? The answer lies in the invisible fabric that binds them: gravity. The primary weapon of a cannibal galaxy is the tidal force. You know tides on Earth, where the moon pulls the ocean. In galaxies, this is scaled up to apocalyptic proportions. As a small dwarf galaxy approaches a giant like the Milky Way, the gravitational pull on its front is stronger than the pull on its back. This stretches the dwarf galaxy, spaghettifying it into a long, thin stream of stars. This process, called tidal stripping, is the first stage of digestion. The predator galaxy peels the victim apart, layer by layer, leaving stellar streams wrapped around it like mummy bandages. But gravity does more than just pull. It creates drag. This is a phenomenon called dynamical friction, or Chandrasekhar friction. It is magical because it creates drag without air or contact. Imagine a massive dwarf galaxy moving through a sea of dark matter and stars. As it moves, its gravity pulls the surroundings toward it. By the time those particles fall toward the dwarf has moved on, leaving a wake of high density behind it. This wake acts like a gravitational anchor, pulling backward on the galaxy, draining its energy, and causing it to spiral inward. This is why major mergers happen relatively quickly, while tiny satellites can orbit for billions of years. Once the galaxies merge, they undergo violent relaxation. The gravitational floor of space-time shakes, shuffling star orbits so thoroughly that they lose all memory of where they came from. The delicate flat disk of a spiral galaxy is destroyed, replaced by a 3D swarm of stars buzzing in random directions, forming a boring, blob-like elliptical galaxy. While the stars dance, a darker drama unfolds at the core. Almost every massive galaxy hosts a supermassive black hole. When galaxies merge, these monsters wake up. Tidal forces act like a cosmic spoon, stirring up gas and funneling it directly into the black hole's mouth. This turns the center into an active galactic nucleus, or a quasar, shining brighter than all the stars in the galaxy combined. This is the scream of a dying galaxy. The black hole feeds so fast that it blasts radiation outward, blowing away the remaining gas and quenching any future star formation. It ensures the new galaxy will be red and dead. Eventually, the two black holes themselves will meet. They sink to the center via dynamical friction, forming a binary pair. There is a theoretical hurdle here called the final parsec problem, where they run out of stars to interact with and should technically stall forever. But we know they merge because we hear the gravitational waves. When they finally touch, they release more energy in a fraction of a second than all the stars in the observable universe combined. We can actually see these stages in the sky right now. It is like a fossil record. We see the Whirlpool galaxy, M51, connected to its victim by a bridge of gas. We see the Mice galaxies, where the collision has whipped out long, straight tails of stars. We see the Antenna galaxies, a chaotic mess of pink and blue, undergoing a starburst, where stars are being born at a frenetic pace because crashing gas clouds collapse and ignite. And we see the Cartwheel galaxy, where a bullseye hit created a shockwave ring of fire. But recently, the James Webb Space Telescope has rewritten this narrative. Before Webb, we thought the early universe was slow to build big galaxies. But Webb found monsters. It found galaxies at redshift 7 to 10, less than 800 million years after the Big Bang, that were shockingly massive. This suggests a process of hypercannibalism in the early universe, where dense groups of protogalaxies collapsed into each other rapidly. Webb even found a group called the Quintet at the dawn of time, proving that group cannibalism started very early. It also found ZS7, a system with a merging black hole when the universe was only 740 million years old, implying that the monsters were awake and feeding almost as soon as the first stars turned on. Now, let's bring this home. We are living inside a crime scene. The Milky Way is a cannibal. We are currently digesting the Sagittarius dwarf spheroidal galaxy. It loops over our poles, and we are stripping it bare, creating a river of stars that wraps around the entire sky. In 2018, the Gaia telescope revealed the corpse of a massive galaxy called Gaia Enceladus that we ate 10 billion years ago. It hit us head-on, puffing up our disk. And right now, we are harassing the Magellanic Clouds, ripping a stream of gas out of them. But there is always a bigger fish. The Andromeda galaxy is heading toward us at 110 kilometers per second. In about 4.5 billion years, it will fill our horizon. We will crash. Our solar system will be flung to the outskirts. The two spirals will be destroyed, and we will merge into a single giant elliptical galaxy nicknamed Milkomeda. Any civilization born in Milkomeda will see a sky of uniform yellow haze, with no evidence of the spiral arms that birthed us. This brings us to the deep science of how we know this. We use chemical archaeology. In a normal spiral galaxy, the center is rich in heavy metals, and the edges are metal poor. It has a steep gradient. But a cannibal galaxy has a flattened gradient. The merger mixes the bowl, sloshing metal-poor gas to the center and metal-rich stars to the edge. By reading the metallicity of stars, we can reconstruct the history of meals eaten billions of years ago. It is easy to feel insignificant when discussing the collision of objects weighing trillions of suns, but this violence is the reason we are here. Star formation peaked 10 billion years ago during the era of maximum cannibalism. These collisions compressed gas and forged the stars that created the oxygen and iron in our blood. We are the debris of a billion-year-old feast. Galactic cannibalism destroys structure, yes, but it drives the chemical evolution of the cosmos. As we look up at the Milky Way, we are not looking at a painting. We are looking at a predator in mid-meal, digesting the past to build the future.